Okay. So, today we begin a new topic. It is one special kind of systems called constant coefficient difference equation based systems. In short, equivalently, we also call it rational systems or even models. I prefer this description. Suppose there is a system, I am not sure whether it is linear and shift invariant, that has to be established, but there is a system that takes an input x n, produces an output y n. Y n is operator t, system operator t working on x n. All right. Now, it is given this system works in a particular way, that is output and its past samples are related to input and its past samples in this manner. Y n, then a constant coefficient a 1 times y n minus 1, then maybe y a 2, y n minus 2 dot 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 a p y n minus p is equal to b 0 x n plus b 1. Again, this is a constant coefficient b 0, this is a constant coefficient b 1, then b q. All right. This given this, you see, you can work out it this way, keep y n on the left hand side, then you have got this thing, these terms from y n minus 1 to y n minus p, you can keep them to right hand side. There is a 1 y n minus 1 plus dot 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 a p y n minus p, and then again the x terms, x n terms b 0 x n. Here, if suppose the past output y n minus 1 to y n minus p they are known, and input of course, current input and past input they are known, then you can carry out the right hand side calculation and you get y n. Then when you go for next index y n plus 1, then this becomes minus a 1 y n, then a 2 y n minus 2, sorry n minus 1, and dot 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 dot, and again b 0 x n plus 1, because n plus 1 is the current index, and dot 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 dot. Essentially, the y n which you compute now, that you put back here, and these past output terms are already available. There is a current input will be x n plus 1 and past input terms are available. So, this is not a problem, and you get y n plus 1. Then again at the next index n plus 2, put it back here. So, and this way it continues. Okay. That is as an example. Suppose your equation is like this, y n plus a y n minus 1 is equal to just suppose x n. So, you keep y n on this side, left hand side is, right hand side is a y n minus 1 minus x n. Then, so if past output is known, a y n minus 1 is known, x n is known, right hand side is known, so y n is known. Next, when you move to y n plus 1 in this equation, it will be minus a y n minus plus x n, sorry, plus x n, y n already calculated. So, put it back here and it will be x n plus 1, x n plus 1 because the current index is n plus 1. So, this is known. Second, y n plus is known. Then go to y n plus 2, it will be minus a, 1 index less. So, n plus 1 plus x n plus 2. This is the current input known, y n plus 1 already obtained. So, y n plus 2 known, and this way. So, from y n you get to know y n plus 1. Y n plus 2 uses y n plus 1, which is computed already. So, recursively you go forward from y n to y n plus 1, y n plus 2 like that. But alternatively, you can also write it like this. So, this equation, let me go through this, I mean use this as an example, that is, instead of writing the general equation, I can as well explain the same thing through just these examples. So, let me do this. This was the equation. Maybe you can keep this on the left hand side, take the other one on the right hand side and divide by A. Okay. In this case, if y n is known, x n is known, you can get back y n minus 1. Okay. Then from y n minus 1, you can go further to the left, that will be 1 by a x n minus 1 minus y n minus 1, but y n minus is already obtained and this is the input. So, again you get y n minus 2, then you can get back y n minus 3 this way. So, it is a leftward movement from y n to y n minus 1, y n minus 2, etc. There is a non-causal movement. We will not consider that movement. That is, given a difference equation, we will assume past output values are known, you calculate y n. Then using y n and other past values, calculate y n plus 1. Then using y n plus 1, y n and still past values, calculate y n plus 2. So, go in the forward direction, y n plus 1, y n plus 2, etc. This is the model we will take. Okay. So, I rewrite again, our equation is okay, this is the equation I just rewriting, and we assume, let us assume that the system is switched on at a particular time, say n equal to 0. Okay. That is, at n equal to, system is switched on at n equal to 0, system is switched on, meaning you give input x n. X n is given, and at that time you have got p initial conditions, p initial conditions given, that is, at n equal to 0, if you use that y minus 1, y minus 2 dot 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 y minus p. These p values are given to you. Okay, these p past values are given to you, they could be 0 or they could be anything. Now, you are using the system from n equal to 0 onwards, that is, you give your first input at x at nth point of time at n equal to 0, x 0, and using that past input, they may be 0, you can calculate, they are 0 because you are switching on at n equal to 0. So, you can calculate y 0. How? Y 0 will be, you take these things to the left right hand side, minus 1 dot 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 minus a p y n minus p, and then you have only b 0 x 0, because past input, because I am switching on at n equal to 0. So, no input was given, input was 0 before that. So, just b 0 x 0, using that you find out y 0. Then you go to y 1, y 1 will be what? You take this side on the these terms on the right hand side. So, minus a 1 y 0, because n is 1 now. So, minus a 1 y 0, y 0 is already calculated, put it back, then minus a 2 y minus 1, y minus 1 initial condition is given, dot 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 dot, and then b 0 x 1 and b 1 x 0. These two input values are known, use them, get back y 1. Then from that you get back y 2, dot 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 dot. All right, this is how we proceed. But these initial conditions on y are required, because at n equal to 0, past input are 0, current input is present, b 0 x 0. To find out y 0, you need these values, y minus 1, because n is 0, y minus 1, y minus 2 up to y minus p. Then again at n equal to 1, you have y 1 plus a 1 y 0, y 0 already obtained, but then after that you have got a 2 y minus 1, still you need past samples, then a 3 y minus 2 dot 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 dot, put those initial conditions, right hand side b 0 x 1 plus b 1 x 0. So, calculate that, input is known, so right hand side is no problem, using them find out y 1, then y 2, y 2 means y 2 is, take this on the right hand side, minus a 1 y 1, y 1 already calculated, then minus a 2 a y 0 already calculated, then minus a 3 y minus 1, use the initial condition, dot 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 dot, plus b 0 x 2 plus b 1 x 1 plus b 0 x 0, they are known, input is always known, that is not a problem. Okay. This is how recursively you calculate. This is the situation. Question is it a linear system? Is it a shift invariant system? That is the question, that we do not know. But before that, before answering that, we will see one particular property of this system, that is, first I will consider two scenario. Okay. One, input x n is 0 for all n, that is, I will not give any input, input is permanently held at 0, and you solve this equation, solution, the solution you call, solution of this equation we call y t n, it is basically we call it transient solution, t for transient, that is, in this equation how you proceed. Okay. Y 0 will be minus y 0 will be minus a 1, that is, we are using all the initial condition, use all the, this is very important, use all the initial conditions, that is, input is 0, right hand side is 0, left hand side to find out y 0, y 1, y 2, you use all the given initial conditions, the given initial conditions I use here. So, minus a 1, so y 0, what will be y 0? Take this part on the right hand side, minus a 1, y minus 1 dot 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 dot, minus a p, y minus p, y 0 obtained. Then again y 1, if it is y 1, then right hand side will have minus a 1 y 0, minus a 2 y minus 1 dot 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 dot, y 0 already obtained, y minus 1 is used like that. So, this is how you build up this solution, which you get y 0, y 1, y 2, I call it transient solution, and instead of calling it y, I put a subscript t. Okay, these are initial conditions. So, these are no need to put a t here, but they are given to you in that form. Okay, y t 0, y t 1, y t 2, y minus 1, y minus p are these initial conditions that I put back. When I am using y t 0, I need y minus 1 to y minus p, those values I put back, I get y t 0. Then y t 1, I need I have to find out minus a 1 y t 0, because n is 1, y t 0 already obtained that part, then minus a 2 y minus 1, okay, put the initial condition, that is, I am equating y t minus 1 with given y minus 1, y t minus 2 with given minus 2 dot dot dot, y t minus p with given ones. That is why y t 0 will be minus a 1 y t minus 1, but y t minus 1 I am taking to be the given initial condition y minus 1, minus a p y t minus p, y t minus p I am taking to y minus p. Okay, the full initial condition I am using here for y t, that is, this solution satisfies the initial conditions, okay, for n equal to minus 1, minus 2 up to minus p, that is the assumption. So, whenever I have y t minus 1, I replace it by y minus 1, y t minus 2, I replace by y minus 2, that is what I have been doing in these equations, you get a solution. This I call it transient solution, all right. So, that means, if I put back the transient solution here on the left hand side, right hand, this will amount to 0, because right hand side was equal to 0, and that is how I solve the equation, right. This is one solution. Another solution is, I am constructing some solutions, transient solution, another is called steady state solution. Okay, steady state solution means assume 0 initial conditions. This solution I call y s, s for steady state n. So, here I assume 0 initial conditions mean I assume y s minus 1 dot 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 equal to y s minus p, that is this sequence, this solution at minus 1, minus 2, minus p, they are all equal to 0, and putting them I solve this equation. Okay, y, that is I solve y s n plus a 1 right hand side does not change, all right. This equation I solve like the way I told you how to solve. Y s 0 will be minus a 1 y s minus 1, but minus 1 is 0. Then minus a p y s minus p, because n is 0, but that is 0. Only b 0 x 0 will come up, so on and so forth. Okay. This solution is y s n. Then my claim is total solution. If you solve this equation for the given initial condition and given input, you want to solve this equation. Then my claim is the solution, if I call it y n, that y n will be summation of y t n plus y s n. That is what I have done. First, I consider two special cases of this equation. In one case, input was 0 and this equation was solved, that is right hand side was fully 0, and equation was solved by using the initial conditions, given initial conditions here. I assumed, I called the solution to be y t n, transient, and if I put that y t n here, I get y t n from its past samples. So, y t 0 requires y t minus 1, y t minus 2, but those y t minus 1 I took to be y minus 1, y t minus 2 be y minus 2 dot dot, where y minus 1, y minus 2 are given to me. Using them, I recursively build up the solution, I call it y t n. That is one special case, right hand side was 0 and initial conditions were used up. Another special case of this equation is assume 0 initial condition and solve. Solution is called y s n, steady state solution. I am assuming y s minus 1 equal to dot 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 y s minus p equal to 0. And then if you solve under that special case, I call it y s n. Then when I am having both initial conditions present, there is initial conditions are not 0 and also input is present, input is not treated to be 0. Like here I took input to be 0, but I am not assuming input to be 0 now. Similarly, here I assumed initial conditions to be 0, but now I am not assuming initial conditions to be 0. That is, I am now considering the general case. Input present, initial conditions present, and then I solve this equation. What will be the solution? My claim is that solution will be summation of these two special cases solutions. How? We will see easily that if I put back this y n on the left hand side, does it satisfy the right hand side? That is the question. So, if I put back y n that is, I have y n means y t n plus y s n. Y s n I am writing here. Then a 1 y t n minus 1 and here a 1 y s n minus 1 dot 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 a t sorry a p y t n minus p plus dot 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 a p y s n minus p, and right hand side is as it is b 0 x n plus b 1 x n minus 1 plus dot 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 b q x n minus q. Question is this true? I am putting a question mark. Is this left hand side in red ink that is equal to this right hand side? That is a question, so I am putting this question mark. Answer is yes, because what is the property of this transient solution? Transient solution was obtained by equating, by putting this y t n in the left hand side, y t n plus a 1 y t n minus 1 plus a p y t n minus p, that is what I have. Right hand side was 0. That means this part was obtained, this part means this part is equal to 0, because that is how the solution y t n was obtained, by equating right hand side is 0, no input, and using these initial conditions, the solution was obtained. That means, if I put back y t n on the left hand side, a y t n plus a 1 y t n minus 1 plus dot 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 a p y t n minus p, that is equal to 0, because right hand side was equated to 0. So, this will be equal to 0. So, this does not contribute anything. On the other hand, this part corresponds to the left hand side here. Okay, it corresponds to left hand side here. That was equated to this part. Okay. So, which is right hand side here? These two are same, which means left hand side is satisfying right hand side. Also, how about the initial conditions? This y minus 1, is it equal to the given one? Answer is yes, because y minus 1 means y t minus 1 and y s minus 1, but y s minus 1 taken to be 0, y t minus 1 was taken to be the given initial condition y minus 1. So, that comes back here. Okay. Similarly, y minus 2. Okay, y minus 2. This y, if you call it y total, say y total n, then y total minus 1 is same as y t minus n plus y s minus n, but y s minus n was 0. So, it is becoming y t minus 1, but y t minus 1 was taken to be given initial condition y minus 1. So, this solution, total solution, satisfies the initial condition at minus 1, similarly at minus 2, minus 3. So, that means it satisfies all the initial conditions, and also it satisfies this difference equation, because left hand side, if I put back, okay, write it as y t plus y s n, y t n plus y s n, and then left hand side is equal to right hand side, because this upper half, which is in terms of y t n plus a 1 y t n minus 1 plus a p y t n minus p, where y t n is the transient solution, this part is equal to 0, because that is how it was obtained. Original difference equation was solved by right hand side, equating right hand side to be 0, that is no input is given, all initial conditions were absorbed on the, okay, in building up the solution there, y t 0, y t 1, y 2. So, if we put them back here, left hand side was equated to 0. So, this means equal to 0. So, this does not mean anything, and y s n was obtained by solving this difference equation, that y s n plus a 1 y s minus 1 plus a p y s n minus p, that is equal to this right hand side. So, that means left hand side altogether is this right hand side, which is this here. So, equality is satisfied, and initial conditions are satisfied, as I told you. So, I am repeating actually. If I call that solution as y total n, okay, is a summation of y t n plus y s n, then y total minus 1 is y t minus 1 plus y s minus 1, but y s minus 1 taken to be 0. So, y total minus 1 is y t minus 1, but y t minus 1 was obtained by equating y t minus 1 as the given initial condition y minus 1. So, this is satisfied. Same for y total minus 2 is y minus 2, y total minus 3 is y minus 3 dot 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 dot. Okay. So, obviously, we can write the solution y total n as summation of y t n plus y s n. Now, this is your input. See this steady state solution is obtained by solving this difference equation, and that has x n as the input and y s n as the output, okay, and same difference equation, but 0 initial condition. So, this is one input, one system, and that has 0 IC means initial condition. It takes input x n, gives you that solution y s n. To this, we add y t n transient solution, then only y total n. You can call it y n, equivalent to y total n. Because what is the total n? The summation of the two. So, we add y t n. How is y t n generated? Y t n is obtained, you see, by taking the input to be 0 and you solve this equation. So, no input and solve this equation by using the given initial conditions, that y t 0, y t 1, y t 2 all obtained from the past, that is the initial condition, given initial conditions, that y t 0 is minus a 1, y minus 1 dot 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 minus a p y minus p, they are given. So, y t 0 known, then y t 1 was minus a 1, y t 0 already obtained, then minus a 2, y minus 1, use the condition and dot 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 dot. So, that means it is also output of a system, but that system takes no input, it uses only full initial conditions IC. Based on the initial condition, the difference equation with input 0 gives rise to y t n. Both these boxes correspond to the same difference equation, but here there is no input, means input 0, and it uses all the initial conditions, that is IC, and build up a solution y t n. This one, the same difference equation, it uses input x n, output y s n and no initial condition. So, solution is y s n, and these two are then added, then you get y n, which is actually y total n as I used here. All right. Now, question is, from this we will be able to understand whether this system is linear and shift invariant. All right. This I do in the next half. Thank you.